All right, today we're going to look at section 3.7, quadratic inequalities, and today I'm going to show you how to solve quadratic inequalities in both one and two variable inequalities. So we're going to start by graphing an inequality in two variables using the same technique used to graph linear inequalities. Okay, so the first thing we're going to do is graph the related function. Then we're going to determine if the parabola is going to be solid or dashed, and then we test a point that's not on the parabola and shade accordingly. So if this test point makes the statement true, then we're going to shade the side that contains the test point, either inside the parabola or outside. If the test point makes the statement false, then we're going to shade the opposite side, either inside or outside. So to start off with, the first thing we're going to do is change this to y equals x squared minus 2x plus 8. So from there, we need to find our axis of symmetry. So x equals negative b over 2a. So 2 over 2 times 1. 2 times 1 is 2, so 2 over 2 is 1. So we're going to take that value, and we're going to plug that into our function for x. 1 squared minus 2 times 1 plus 8. So that's 1 minus 2 plus 8. 1 minus 2 is negative 1. Negative 1 plus 8 is 7. So we have a vertex. We can plug into our table at 1, 7. And then we can pick some points to the left and to the right. They should mirror each other. I know that my y-intercept is going to be 8, so when x is 0, y is 8. And then if I just run negative 1 through my function, negative 1 squared minus 2 times negative 1 plus 8, that's going to be 1 plus 2 plus 8, that's going to be 11. And those mirror 8 and 11. So I now have 5 points I can plot. Now, my graph on this only goes up to 6 spaces. So I'm going to need to make every space worth 2. So my axis of symmetry is going to be at the x value of 1. My parabola is going to have a vertex of 1, 7. So 2, 4, 6, 7. Put the parabola there, or the vertex there. And then we can plot these points. 0, 8, 2, 8, negative 3, 11. Or sorry, negative 1, 11, and 3, 11. So that's step one. We graph the related function. Now we need to determine if the parabola is solid or dashed. And we do that based off of the sign of the original inequality. The sign is less than, not less than or equal to, just less than. So that means we're going to have a dashed parabola. Okay? Now we're going to take a test point. The easiest test point to take is always just going to be 0, 0. So as long as 0, 0 is not on the parabola, use 0, 0 as your test point. So 0 is less than 0 squared minus 2 times 0 plus 8. 0 squared is 0. Negative 2 times 0 is 0. So all that's left is 8. So 0 is less than 8. So we are going to shade the side that has 0, 0 on it. So that is this side that is outside of the parabola. So it is below it and it is all around it. Everything that is not inside the parabola is getting shaded. Now, when you're shading this on your test or something, be careful not to shade inside the parabola. In fact, leave plenty of space between the parabola and where you're shading. I'll know that what you want to be shaded does not have to be perfectly darkened in. So just do it quickly. Make sure that you don't shade the parabola. Make sure I can see your parabola. Make sure I can see that it's dashed and nothing is shaded inside it. All right, so that's how you shade, or that's how you graph a inequality with two variables. Now, to graph an inequality with one variable is very similar. All right, so we're going to do the same idea, but we're going to change the 0 in this case. So our first step, of course, would be get it equal to 0, or move everything over to make it less than or greater than 0. And then we change the 0 to the y, and we change our sign to equals. And then we graph that parabola. And then we identify the x values for which the graph is below the x-axis if we're looking at less than, and if we're looking at greater than, we'll look at above the x-axis. If it's less than or equal to, it's going to be a solid parabola. If it's less than, it's going to be a dash. Okay, so if it's less than or equal to, it includes the x-intercepts. If it's just less than, it does not. All right, so if our A is positive, that means it's opening up. We're going to be looking for points between the x-intercepts. All right, and for those parabolas that open down, if we're looking at using the less than 0, we're going to be looking at x values that are outside the x-intercepts, meaning further to the left and further to the right than our x-intercepts. And the same is true, but in reverse order for whenever we're looking at something that's greater than or equal to 0. So for greater than, we're looking at things that are outside. If our A is positive, we're looking for outside the x-intercepts. So if it opens up, it's going to be outside because that's where it's above the x-axis. And if it's negative, so it's opening down, we're looking at things between the x-intercepts. All right, so let's look at example 2 here. So we're going to solve by graphing. So we're going to graph this parabola, y equals x squared plus x minus 6. So we can find the axis of symmetry same way, x equals negative b, so negative 1 over 2 times 1. So that's going to be negative 1/2. And the vertex would just be negative 1/2 squared plus negative 1/2 minus 6. Negative 1/2 squared is 1/4 minus 1/2 minus 6. 1/4 minus 1/2 is negative 1/4, and negative 1/4 minus 6 is negative 6 1/4. So that is our vertex. So that's x, y. So at negative 1/2, we have a y value of negative 6 1/4. Now find two x values to the left, 2x to the right. So negative 1, negative 2. Actually, let's go ahead and do negative 3. And then we can go 0, 1, 2. All right, so if I run 0 through the function, it's going to spit out that's my y-intercept, so that's negative 6. And so negative 1, negative 6. And then if I run 1 through the function, so that's 1 squared plus 1 minus 6. So that's 1 plus 1 minus 6. 1 plus 1 is 2. Minus 6 is negative 4. And then if I run 2 through the function, 2 squared plus 2 minus 6. 2 squared is 4. 2 minus 6 is negative 4. 4 minus 4 is 0. So there's our zeros. So we can go ahead and plot these points. Negative 3, 0. Negative 2, negative 4. Negative 1, negative 6. Negative 1/2, negative 6.25. 0. Negative 6, 1, negative 4. And 2, 0. Next thing we're going to do is look at plotting the parabola itself, if it's going to be solid or dashed, and it is going to be dashed. All right. So the only thing we had to have is our vertex and our x-intercepts. So once we have that, we have enough to figure out the solution is this. So we're looking for values that are less than 0. So this is less than 0 between these two x-intercepts. If you notice, our parabola is below the x-axis between these two x-intercepts. So, therefore, one end of the domain of the x's that work here is going to be negative 3, and the other end is going to be positive 2, and we're going to bound those with parentheses because those values themselves are not included in our solution set. Okay, so now what we're going to do is we're going to also write this in algebraic notation. So -3, 2 is our interval notation. And then algebraic notation, we could write that as, we could write that as -3 is less than x and less than 2. So our x's are between -3 and 2. So it's this area here between our two x-intercepts. All right, so another example here, x squared minus 3x minus 4 is greater than or equal to 0. So greater than means this time we're looking at when the graph is above the x-axis. Okay, so again, find the axis of symmetry. Well, actually, first thing we need to do is write this as an equation that we can graph. So y equals x squared minus 3x minus 4. So it's going to be 3 over 2 times 1. So that's 3/2 is our axis of symmetry. So 3/2 squared minus 3 times 3/2 minus 4. 3/2 squared is 9/4 minus 9/2 minus 4. In order to combine those, I need like terms, so make everything have a denominator of 4. So 9/4 minus 18/4 minus 16/4. So 9 minus 18 is -9. -9 minus 16 is -25. It's -25/4 or -6 1/4. So we can make our table. Our vertex is at 3/2, -6 1/4. Our axis of symmetry is at 3/2. All right, so then pick numbers to the left or right. So 1, 0, -1, try 2, 3, 4. Okay, so we'll run 1 through the function. 1 squared minus 3 times 1 minus 4. That's 1 minus 3 minus 4. 1 minus 3 is -2. -2 minus 4 is -6. So not too much different there, just a little bit above. Next we have 0. Well, 0 is our y-intercept, so that's -4. So that mirrors there to -4. So 0, -4, and 3, -4. And then the next point we have is 4. So 4 squared minus 3 times 4 minus 4. 4 squared is 16, minus 12, minus 4. 16 minus 12 is 4. 4 minus 4 is 0. So there we have our zeros, -1 and 4. This time, our parabola is going to be solid. So that is our parabola. And we're looking for areas where our parabola is going to be above the x-axis. Notice this parabola is going to go up forever, to the left and to the right. So that means that anything to the left of this x-intercept, it'll be above the x-axis, and anything to the right of this x-intercept. So we're looking for the outside. So our intervals are going to start at -infinity and go until it reaches this first x-intercept of -1. And it is included at -1, so we put a bracket there. Then we have a break, we have a gap. So we have a u. Then we have a bracket, and we pick back up at 4, and it goes to +infinity. And there is another parentheses there. That's how we write that in interval notation. If we wanted to write that in algebraic notation, I would say x is less than or equal to -1, or x is greater than or equal to 4. And those are the values that make this a true statement. All right. So, last thing here is solving a quadratic inequality using algebra. Okay? First thing, to solve this algebraically, again, is to turn this into an equation. X squared plus 15x plus 50 less than or equal to, or sorry, not less than or equal to, just equal to 104. So that the only thing that changed there is changing the sign from less than or equal to equal to. All right, now what we're going to do is we are going to solve this equation like we would always solve an equation. So the first step is to make it equal 0. So we're going to subtract 104 from both sides. X squared plus 15x minus 54 equals 0. Then we're going to factor negative 54 on top, 15 on bottom. All right, factors that multiply to equal negative 54 and add to equal 15. They're going to be positive. One's positive, one's negative. The bigger one's positive because the bottom number is positive. So negative 1 times 54, negative 2 times 27, negative 3 times 18, negative 6 times 9. Well, the one that adds to equal 15 is negative 3 and 18. So x minus 3 and x plus 18 equals 0. So the zero product property states that anytime I have two things that multiply together to equal 0, one of them must be 0. So if I have x minus 3 times x plus 18 equals 0, either x minus 3 equals 0 or x plus 18 equals 0. So x would be x would be positive 3, or x would be negative 18. So, because we're looking at less than, and our a is positive, we're looking for the area between negative 18 and 3. So, and it is included because it's less than or equal to. So, negative 18, comma, 3, bracket. The other way to say this is negative 18 is less than or equal to x, which is less than or equal to 3. So both of those are how we would say our solution set. All right, that's it for today's notes. If you have any questions, please shoot me an email or a Canvas message. I'll get back to you as soon as I can.